Furnace is one of the important unit operation we use in cogeneration and such utility systems. Basic principle of furnace and how the energy balance in a furnace are discussed in detail in this chapter. Supplies of high temperature heat required by process are given through the combustion of fuels in a furnace or fired heater. The basic illustration of a furnace unit can be seen here. You see that normally in the bottom side there is a burner that we use to burn the fuel. The fuel can be gas, LPG, can be liquid, can also be solid like coal. In the combustion chamber, normally around it, it's surrounded by the radiant section. What is the radiant section is, it is a tubes that can be placed horizontally or vertically mounted around to harvest the radiation heat emitted by the combustion. Normally, if we want to recover heat from the furnace, the tubes can be placed around the combustion chamber. So all of the combustion, actually most of the combustion can happen in this section in the chamber, and then after that the uh, the flue gases, any product from combustion is flown through the convection section where actually further recovery of heat can be obtained here. It can be used using seal of shock tubes, fin tubes, and so on. The typical temperature around the convection section is about 700 to 93 degrees Celsius. After this one, then the flue gas is flown through the stack where the temperature is about 150 to 200 degrees Celsius. There are few types. There are two main types of the furnace based on the draft. Draft is basically how the air is forced into the furnace. So the first of the two is the natural draft. So in natural draft, the stack high must be uh, sufficient to provide adequate draft. So you see this kind of furnace that have a very high, very large and very tall stack gas. The idea is to use the stack force to pull the air from the outside of the furnace to the combustion chamber. The draft principle is affected by the difference of density between the hot flue gas and the ambient air. So the ambient air move from the atmospheric to the chamber and then go up to the stack. This type of this type of furnace normally has a low capital cost. However, it is suffer from low efficiency. Another type of the furnace draft is the forced draft. Forced draft furnace use a fan to force air into the combustion chamber. It also can use fan to pull out the um, flue gas from the stack. So in this case, the stack high is not that high because we don't use the stack high to pull out the air from the atmosphere to the furnace. However, it has a higher capital cost due to the requirement of the fans, and the plus point is that it offers higher furnace efficiency. So when design a furnace, there are few of the design parameters that need to be considered. The first one is radiative. It is a convective heating split varies according to the furnace design. So like the sizing of the combustion chamber, and then Normally, uh, the the casing or the insulation of the furnace has to be good enough. As such, we allow only 1 to 3% of the net heat released from the combustion. So we try as much as possible to avoid the heat loss during the combustion. Another thing is that stack temperature must be high enough to avoid condensation if sulfur present in the fuel, to avoid corrosion or acid dew point. So what happens if, let's say, you have a fuel of a coal that has high content of sulfur, so it will become hydrogen sulfide. Okay, when so the sulfur will be burned to become hydrogen sulfide, and then hydrogen sulfide can condense at low temperature, at temperature around 100 to 150. So when it's condensed, the gas is quite is quite corrosive, so it might damage the furnace. So how do an engineer design a furnace? So first of all, it is based on the first principle of mass balance and energy balance. Okay, so when we burn fuel in a furnace, to design the system, first of all, we need to look into the heat balance. So during the heat balance, as you can see here, heat balance basically you have heat in and you have heat out from the system. So what are the factors that where the heat or the energy is bring into the furnace? First of all, it is from the heat of combustion. The when you do the combustion reaction, they produce it's highly exothermic. It produces energy, so the heat come from heat combustion. The next one is the sensible heat of combustion. Basically, the air that come in also carry a certain amount of energy. Okay, another one is the sensible heat of the fuel and atomizing steams. So fuel that come in, it also has a sensible heat, which is its temperature basically. Okay, so from which aspect that heat is taken out from the system? First is that you can transfer the heat, okay, from the combustion chamber to the radiant here, okay, where actually you want that heat to be utilized in the process. Then another one is that the heat that you produce is taken out through the convection section here, where you use a lot of tubes to basically recover the heat from the quite hot flue gas around here. Another factor that utilize heat or that heat go out from the system is through the casing losses. We call it heat loss here. So the heat can go through conduction from the combustion chamber outside, all around the wall of the furnace. And lastly, heat also goes out through the stack in the form of the stack gas, in a form of flue gas. So in the end, the heat of combustion, then we can use a simple energy balance. Heat of combustion equal to this is heat that you utilize, heat from the radiant, heat taken from the convection section, heat goes lost through the casing, uh, heat that is gone through the stack, through the flue gas, and then minus the one that goes in, which is the Q air, Q fuel plus Q fuel here. That's it.